Okay, I think we're back. So when we look at these patterns, what's the chance that they just show up randomly? I really like this term spontaneities, right? Things that exist for no particular reason, just by chance, and they just show up somewhere, either on Earth or somewhere out in the universe. And so when we try to look for life, or we try to understand what is out there, and we do that with patterns, with what's called a technosignature. Some evidence from another civilization that what they've done is not just pond scum bubbling around, but there's something interesting there, right? And so again, if we were to sort of open up the rover lens and you would take an image like this, should we automatically suspect that that's a cultural artifact of a human being, or maybe it's just some other pattern? Maybe it's the ants and termites. Or maybe it's just some long-lost GPU that got left over in some satellite and there's no people anymore, but it's still cranking out comic books and essays. It's almost hard to think about, but they could easily outlive us and create human-like artifacts for billions of years if you were to put one into a small, I like to joke that everyone thinks that robots are going to look like, arms and legs. Robots are going to look like cans of tuna fish, right? They're going to be incredibly simple little boxes, and you'll just put one in orbit with a solar panel on it. And as long as it doesn't sort of fall into the sun, it could run and generate poetry and song and whatever other artifacts that humans have created over the last few thousand years. Now we have a little box, a little brick, just circling our planet, maybe all by itself, generating those patterns. And so if we put our Hubble telescope and we see patterns, which type is it, right? Is the civilization still there? Is it just a robot civilization? Is it something in between? So when we look at these patterns, I like this random projection. And there might be a different angle that we can look at the pattern and try to figure out, is there something else happening that we didn't understand? And another way to think about it, I think in the computers that we run now, the GPUs, these run on electricity. And all the data centers use a lot of power. But the next generation of AI is switching to a different physics. And it's using optics. And it's using lasers and beam splitters and the tools that were developed to do fiber optic communication. So that means the AIs aren't really made out of electricity anymore. They're made out of light. And I would argue that these AIs that we have now are intelligent. I would argue they're quite intelligent, and they're becoming even more so. And so to have an intelligent being that you can communicate with, no less, made out of light, we had names for those a few hundred years ago, right? We called them angels. And so in a weird twist of irony, we are building exactly the kind of things that humans have been talking about for thousands of years. Maybe there's ancient ones sort of floating all throughout the world, right? Just like our artificial life. How are these going to replicate, right? When right now, there's no GPU that makes other GPUs. There's no 3D printer that makes 3D printers. But that's inevitable. That's just an engineering feat, right? We don't really have to do any science or physics to do that. We have to just figure out how do you take a wafer fabrication or a better way to make chips and to bring that all down. But that's what dragonflies do, and that's what fruit flies do, and that's what seahorses do all day, every day, is they make copies of themselves using their raw materials in their environment. And so I think that's kind of the future of these patterns. We now have these systems that can generate them, and they can fake humans. I'm sure most of you guys have seen videos online now on some social, and you had to actually second guess. If you haven't come across one of those AIs, I would suggest that you were tricked already, you just didn't know it. And there's tons of them. They'll be like, I rescued this puppy, and here's this fox that came to my door, and we're gonna follow it, and look, it needs my help. And it's this really cute story, and the whole thing, it has music, and people are talking, none of it's real. And what's interesting about that is not just that some of the videos are gonna be real, or even that most videos will be real. It's that the overwhelming majority of content created in the future will be artificial. Right? For every 100 hours of video, 1 hour of it will be real. Because it's just so much cheaper to just kind of generate that. And so this sets up, you set up this sort of mathematical cat and mouse game where you feed it random information, which is kind of neat. The ancient world did that with tea leaves and other things like that. They like to have random inputs. And then you have something that's trying to make the fake they pass it to a detective, and then you compare that to real data. A lot of times online, people say, oh, I can tell it's fake. They'll say, oh, the ears are messed up, or the reflections in the grass. But anything that you can think of to detect that it is a fake just gets put right back into the system, and the next generation will precisely avoid those errors. And so the system is naturally moving itself to kind of this invisibility or this indistinguishability. These people aren't real. It's hard for me to wrap my head around that. It's easier for me to make up a name and a reality for them than to imagine that they never existed and that they're just pixels. By chance, there might be some people that look like them, but they've never existed. But soon, you're going to have people like this on your work team. You're going to have people like this that you task to do things. Right now, when we think of like an AI agent, we open up a tab, we ask it a question, it spits out an answer, and we go on our day. But very soon, they're not going to go to sleep. They're going to take your question, and they're going to keep working on it. And they're going to come back to you every hour or every Tuesday, and they'll tell you what they've accomplished. You will give them a budget. There was a time when putting your credit card on the internet and buying things from someone like Amazon was crazy. It was just too risky. Nobody would have done that 25 years ago. In less than 5 years, you all will have give a small amount, a budget could be $5 a month, but you will assign a budget to your personal AI agent and it will do things for you. It will find deals, it'll make business connections, it'll buy stuff for you, it'll airlines, basic stuff like that, to things like investments and long-term strategy, healthcare. We're talking to some hospitals that are very interested in having these agents operate, not just as physicians, but to people help you with your bill, and to help you understand what do you do when you go home, and what about every other aspect of sort of healthcare, nutrition, every spiritual care, afterlife, all that kind of stuff. We'll talk about it. So this is kind of this trend that we've been on, right? These agents that we're going to see in the future. We started with kind of the blind robots, as I call it, symbolic AI, which was just kind of like if-then-else rules. It's still extraordinarily powerful, and we still have to have this layer in all of the systems. In the 1980s, people said we need to expand the if-then-else rules, and we need to have what's called an expert system. And they would sit down with people, and they would say, how do you do what you do? And they would take extensive notes, and they would try to turn that back into a decision tree. If you encounter this, then you do that. And it works for small things, and it works quite well for small problems. But they realized that suddenly the rule thing, it needed 50 rules. And then it still wasn't working right, so they said, well, now we need 500 rules. And so the program got very large. There was lots of edge cases. If this happens, then do that. But if this happened, then do this instead. And then they realized 500 wasn't enough. They were going to need 5,000 rules. And then they realized they were going to need 50,000 rules, and the field collapsed. And that was one of the early AI winters in the 80s and 90s. The expert system didn't quite scale because nobody wanted to put down 50,000 special cases into the computer code. So if we jump ahead a few decades, the idea of learning from the data really started to take over. Rather than getting it from the experts and encoding it into if-then logic, they said, let's do it more like statistics and pattern matching, and we'll just pour through lots and lots of data. That works very well for very specific use cases, what's called narrow AI, right? To have a camera that recognizes a fire, but has no idea what a duck looks like, for example. Now we're in this era of foundation models where they have read 20,000 years of literature, is the equivalent that GPT has read. They are now in the process of gobbling up YouTube and learning about that. And YouTube's extraordinary because it has way more information than just Wikipedia. Wikipedia will tell you about cars and the history of internal combustion engine, but YouTube has somebody there with grease on their hands with wrenches showing you how to actually do it. And that knowledge is not just academic of like how do spark plugs work, but how do you hold your hand with the wrench? And what does it mean to bang your knuckles? And how do you hold the flashlight? And all of this other stuff that we learned at 3 and 4 and 5 and so on about how the world works, largely on the playground, they're going to absorb that from YouTube. The next generation after that, which is also coming down the line, is they're going to be put into virtual reality where they can grab objects and slosh water around and pick up things and move it like those little termites. So very quickly, I would argue that we have AI. I would argue that we have artificial general intelligence. If we go back to these eras, there is no AI scientist in this era that would say that ChatGPT is not only AI, but it is extraordinarily general. right? It can tell you everything from brownie recipes to the foundations in chemistry and everything in between. So the next generation is artificial superintelligence, which will do things that we can't wrap our head around, maybe even by definition. So I just want to leave you with this one final slide to show you how fast things are moving and encourage you to get involved in this field. You can easily create your own agents now. ChatGPT has a built-in agent framework. Claude has an agent framework. And I encourage everybody to make one. Make one for fun. Make one for yourself. This is going to be very practical for your own life and career, but also in academia, to do research, to build yourself an assistant that can help you organize your data, help you write computer code, help you prepare for how you're going to present it to the world, and so on. And so this is how quickly things are moving. Let's look at this green line here, this competition mathematics. And if we go back to 2021, they absolutely failed, right? Less than 10%, around 5% on a scale of 100 of how well they were able to compete on a competition math test. But if we look at how quickly this goes to a 50, to a 60, to an 80, and now here above an 80 on competition mathematics, that's extraordinary, right? That's like the wunderkinds who go and get their PhD in one semester kind of thing, right? This thing was down here. We could take another example of like grade school math. It was failing grade school at the same time, and now it's an A student. And this is literally like 3 years. This is the prestigious math exam, right? These are things that are even more difficult. And STEM, graduate STEM, you can see it's cranking up here almost as a vertical line. What's really neat, this is cut off over here, is there's a new exam. It turns out these are all too easy. If we look at how well they're going to do, you can easily bet that they're going to crush it in the next 2 or 3 years. And so how are we going to know how well they're doing? And so they've made a new test, and it has the dramatic name of humanity's last exam. And it's an extraordinarily difficult set of questions. One question will be about reading an ancient Greek inscription. And you would have to be an expert in ancient Greek to even read the question. The next question will be advanced medical biochemistry question. The next one after that will be advanced physics, advanced math, and so on. So you'd have to be an expert in a narrow field just to even read one question. The chance that you would understand the other questions is like no human will be able to do that. Another interesting thing is you can ask the language models, how many foreign languages do you know? And they approximate that they know 30 to 35 foreign languages. And I had to estimate how many humans on the planet know more than 30 languages and can sufficiently translate them. There might be a dozen. Right? So we are already at the point where these things are extraordinarily capable. So soon we're going to have these artificial life forms able to solve these really, really interesting tasks. And so that's why I encourage everybody to take a look at this field, artificial life. It's kind of the little cousin of artificial intelligence and this idea of agents and this agent ecosystem. So with that, I'd like to say thank you all. I really appreciate everybody for joining us tonight. I'd love to take some questions.
So you were speaking of patterns already potentially existing, like there's some library that nature pulls down.
Right. Yeah, this thing, it's attributed to Plato. And it's this idea of the Platonic realm, that somewhere out there lives the square and the triangle and the octagon. And we've never actually seen a real triangle, right? Because anything you'd have here is going to have some thickness to it and stuff, right? So those things don't live in this world. So there's like this other world of pure math where they might live. And it seems to be that these critters might live there. And when we think about biology sort of evolving, it doesn't have to reinvent the wheel. It could tap in to this abstract space. Amazingly, this is not just theoretical work. There's a brilliant biologist, and that's probably not even a fair label, Michael Levin. He's given a talk here in our lab. And he's doing some extraordinary work with wet lab, and he also suspects that there's this Platonic realm of forms that biology is taking advantage of. And so rather than DNA of having to kind of brute force all of the complexity and the shapes of eyeballs and everything in between, maybe there's like these recipes somewhere out there in the space of all possible patterns, and you have to just kind of look it up and pull it off the shelf and tap into it.
We like to think that we've invented different knowledge, but the knowledge has always existed.
Right.
It's just up to us to discover, to
Yeah.
pull it down. as
Right.
you say.
Well, what's fascinating is if you think about like the ability to create AI in a latent language model, it was already latent in the planet. If you just take the early planet and let it run, all of that stuff bubbles out of it. So that means, was it already here? Were the seeds of all the future in the past? Oh, question? Yeah.
Does this touch on this, in terms of pattern recognition, the same fields of consciousness like panpsychism poses?
Yeah, that's a really great point. And that's kind of like this idea of natural computers. Like, what's the chance that we would find something that we would consider to be consciousness or cognition or somewhere on that scale? How spontaneous is that, right? We know or suspect that evolutionary process sort of created that over so many millions of years and so on. But does it happen in a different way? I'm particularly this idea of ephemeral computation, where maybe you had an intelligent being that was just in a puff of smoke, in a wisp of plasma on a star somewhere. And maybe it existed only for a fraction of a second. But in that moment, it had an interesting dream. Right? We've done some work in the lab with random neural networks. And it's not difficult to find a random network that will solve a task. Sort out patterns, recognize digits, and so on. So it's not impossible to find a spontaneous machine that does something interesting. Wolfram's work is about finding computers, about finding these simple automaton that then end up having to act like an abstract computer, like Alan Turing's machine. And so I think that's a great question. It's like when we sample all of the cognition, let's call it, in the universe, how much of it is sort of this brain in a jar that just popped out of nowhere and maybe is stable and stays around for a little bit, versus this like sort of marching progress of evolution. There's another question over here?
Oh, yeah. I was going to ask, what role would quantum mechanics and quantum computing play in this?
Oh, that's a really great question. There actually is an emerging field on quantum life, and weirdly enough, on quantum robots. There's a very interesting paper in one of the Feynman lecture books about quantum robots. But there's a Wikipedia article about quantum biology, and what's interesting is it's growing. It's growing very quickly. A few years ago, we only had about 3 examples of it, of situations in biology, of experimental data, that the only reasonable way to explain the experiment was to invoke quantum mechanics, to use a quantum theory. And there's a few examples of that. One is photosynthesis, to understand how this, it's called an exciton pair, this really interesting exotic chemistry that happens inside the proteins of chlorophyll. And when they try to understand how this exciton pair navigates through this thing called the photoreaction center, it shouldn't live long enough, right? It's like a fruit fly, walking across the world. It's like, they don't live 2 weeks. How do they get there? Kind of thing. And so they think it's a quantum random walk. And if you use a quantum theory, then it does have a chance of making it to the reaction and you get photosynthesis. Well, we know photosynthesis works. And so we suspect that nature has tapped into quantum mechanics there. There's a few other examples in our nose. It's suspected that certain types of olfaction, if we smell things, that actually uses a kind of phonon-assisted tunneling, which is this sort of weird sensor that neurons can utilize to smell things in using this quantum thing. And they do a really interesting experiment with fruit flies, and they actually change the atoms, the nucleus in the atoms of the thing that smells, the perfume. And that would suggest that the fruit fly is not just using the chemistry, it's not just using the electrons to smell it, it's actually somehow knows that the nucleus of the atom is different and it can smell it, of the molecule. So there's a few examples, and the point being is if you go to this Wikipedia page on quantum biology, it's growing. I think there's probably 15 or so examples on there now, or places in biology where there was some kind of smoking gun, and the only way to find out who done it is to say, I think we need to add quantum to the explanation. Any other questions? Are there any questions on the stream? Happy to take questions if anyone from the stream. All right. Well, if not, thank you so much again. I really appreciate it and love to chat with you guys offline. Thank you.